couple things. The homework assignment from yesterday is not due until tomorrow at 8:15 a.m.
So you won't believe what I did. I just left my computer at home. No access on your homework.
Dude. Alright, so the reason I do that is because at least the first time that we have a delay in a homework assignment, it's I know Blaze was going to come to school, or Carter was going to come to school, or somebody was going to say, man, I was counting on Wildcats on doing my homework, and now I don't have it.
Oh, yeah.
Or, you know how some of the periods are jockeyed around, right?
Yeah.
So I always get that person from 5th period to say, well, I had 4th period study hall, I was going to do it then, but then it got switched to after 5th period. Understand, from now on, okay, this is the only time I'm going to do this, from now on, a due date is a due date. Is that alright? Okay. So, you wake up tomorrow morning at 7 o'clock and you get the text alert that school is delayed. But you procrastinated, did not do your homework, and we're going to put it off until class time. Well, class starts a little bit earlier, or later, I guess, than what it would have or on a regular day, right? Does that make sense? So, when it is a due date, and there's a cancellation or delay, that due date is still what it was. And you need to get up during that 2-hour delay if you didn't do your homework yet and finish it, okay? And then go back to sleep. Does that make sense?
Yeah.
Okay? I want you guys to learn not just the math, okay, not just the science that I talked about, but I want you to learn how to operate at the next level. You go to college and they give you a due date, it's due then, okay? There's no extensions, okay? You go to a workforce and they tell you to have this project done or have this work done at a certain time and you don't, you reap the consequences there, right? Okay? So I want you to learn those things here. I'm not just about the math, just about the science, but learning those skills of how to navigate through the real world as an employee of somewhere, or maybe you go to the military, something like that. You have to abide by those things, right? So getting you to pay attention to detail, pay attention to due dates is a huge aspect, I think, that some people don't really realize. Okay, and hopefully get you to realize that now, make the rest of your life a little bit easier. So due dates are due dates. That being said, we're not going to talk about that homework until tomorrow. Okay, so we're going to move on to section 1.7 today. There's a couple sections in this chapter that I'm not going to get to because we'll put them at some other point, like perimeter and area. They have a better spot later on in the year. And in addition, they're really not telling you anything new in those sections that you don't already know. Okay, I talked to our in-service this last Friday, was talking to younger grade teachers, like the 7th, 8th grade teachers, 5th and 6th grade teachers, and we talked through the standards and stuff that they teach and that kind of stuff. Area and perimeter, one of those things you learn in 7th grade, 8th grade, 6th grade. All right. So what I want to do, I want to talk about the midpoint formula. Okay, finding the midpoint of something. So if I look at, we're going to first focus on dealing with very simple segments. Okay, so if I take a segment that has a point at 6 and a point at 24. Okay, very simple because it's horizontal. Okay, there's no vertical movement there from A to B. All right. Now, if I ask you to find the midpoint, how can we do that? Carter?
24 minus 6 divided by 2.
Okay, 24 minus 6. So that's going to give you what?
How far apart?
Okay, it gives me the span or the length of that segment, right?
Yeah.
So it gives you 18. Now you're dividing that by 2. So you get 9, right?
Yep.
So what are you going to do with that 9? You're going to go put 9? Because 9's right there.
Yeah.
Is that the midpoint?
No, you can probably put like point C or like point M for midpoint.
Okay, but it's going to be located at 9?
No, it's going to be at 4.5.
At 4.5?
14.5.
Why 14.5?
Because if you take 6, that's 15, plus 9, 15.
15. Okay, so you're going to take the 9 that you found, you're going to add that to one of your endpoints, right? This endpoint, your first one, and it's going to give you 15. Can you take 9 and subtract it from B?
Yeah, I guess.
Okay. Is there another way that might be a little bit, because there's nothing wrong with that. Is there another way that might be a little bit easier?
Yeah.
How can I take those two numbers and add them? What do you get?
30.
30.
Divided by 2.
Divided by 2 is
15.
15, which is exactly the number you got when you added 9 to 6, right?
Yeah.
But isn't adding divided by 2 just a little bit quicker?
Yeah.
Okay. So, what we're going to do, I'm going to give you two formulas here, but they're really the same thing. You're going to see them written differently from time to time. First formula is, they're going to call that coordinate lowercase a. We're going to call that coordinate lowercase b. Alright? And then the formula for finding the midpoint is a plus b divided by 2. A plus b divided by 2. Okay? If I asked you guys, let's say we got 15 people in here, and I asked each one of you what your GPA was, and I add them all up, and I divided by 15. What did I just find?
Our average.
That average. If I take A and B and add them up, and divide by how many endpoints we had, what did I just find?
The middle.
The middle, which is just a
Average.
average. Okay? So you're going to hear me from time to time say that the endpoint, or the midpoint, is simply the average of the endpoints. That make sense? Alright? And you can do this no matter what your values are, whether they're positive, they're negative, they're fractions, whatever. Now if I take this segment, we move it to where A is at -4.
Yeah.
Okay, and B is at 30. Okay, what's -4 plus 30?
25.
Huh?
25.
-4 plus 30.
26.
26.
30.
26 divided by 2?
12.
13.
Oh.
Okay, so when I put that point in as the midpoint, you see that it's at 13, right? Is that doable?
Yeah.
Alright. So A plus B over 2. Another way you're going to see it written, and this is the way I prefer to write it.
This is the way I told you.
What is the horizontal axis? Which variable do you refer to that as?
X.
The x-axis. So I call that x, and I call that x. But if I say everybody look at x, are some people going to look at -4?
Yeah.
And some people are going to look at 30, right?
Yeah.
Alright, so we need to put some subscripts on there to differentiate. So I put 1 there, and I put 2 there. And those are just kind of like a first name, last name idea. If I had 4 people in this room named Cole, and I said, everybody look at Cole, we got people looking at different people, right?
Yeah.
If I said everybody look at Cole Hammer, now we got 18 sets of eyes looking at Cole Hammer, right?
Yeah.
So if I say everybody look at X1, we got everybody looking at X1. If I say everybody look at X2, everybody's looking at X2. Okay? So I write the formula now, instead of A plus B, I write it that way. And that way, you're going to recognize why we do that here in a little bit. That becomes very useful to write it that way, instead of the A plus B. Is that okay? Alright.
Yes.
And that's how you find the midpoint of just a horizontal line. Well, if I'm going to find midpoints of horizontal lines, why can't we find midpoints?
Vertical line.
Exactly. Okay, so if I want to find the midpoint of a vertical line, let's go from -5 to 15. Okay, what do I get if I add those two together? 10 divided by 2? 5. So my midpoint would be at 5. Okay. Now those are y values, right? It's the way that's the axis we think about. So I can call this y1, y2. And now the average would be y1 plus y2 over 2. Okay? And that's how you find midpoints of just horizontal or vertical lines. Or a lot of times they refer to them as just like one-dimensional line segments. Okay? Or one-dimensional number lines. Alright? Now what becomes a little bit more difficult, not much, because all we're going to do is combine these two ideas, is when I want to find the midpoint.
Oh, when they're crisscross.
Crisscross.
Applesauce.
When we have something like that. Okay? Because now it's not strictly horizontal, right?
Oh.
There's a vertical component to it. Okay, so we got horizontal and vertical components working here. So we have to adjust our way of dealing with it because of that.
I don't know how to do it. Solve it.
Well, let me ask you. Let me kind of guide this a little bit. But when we get to the point of solving it, I'll use you. Whenever you see a segment drawn in the coordinate plane, the XY axis, I want you guys to realize that that segment is always a hypotenuse. Okay? And what's a hypotenuse belong to?
Triangle.
What kind?
Right triangle.
A right triangle. Okay? If I take... and develop those two segments. Let me change their color so we can talk about it a little bit easier.
Big one, red.
Sorry. Are you trying to hit on me, Cody?
So we take those two blue and pink lines and they become the legs of a right triangle, correct?
Yeah.
And no matter where I move the endpoints of the orange segment, I can always readjust. So maybe my orange segment goes there. Can I readjust
Oh yeah.
the blue and the pink to create a right triangle?
Yeah.
Yes.
And if the orange one goes there, can I readjust
Yeah.
to make a right triangle? Okay? So, the right triangle becomes a very practical, very useful tool for us to find midpoints. Okay? And all we're going to do is we're going to realize that we need to find the midpoint of the blue segment. Okay? So if I look at the blue segment, let me get this thing to show these ordered pairs. Okay? If I look at this blue segment, okay, any point that I choose on it is going to have a y value of what?
10.
It's going to have a y value of 10. So I'm not really worried about the y value. I know what that's going to be. But I want to find the x value, the coordinate of the midpoint in regards to the x value. Okay? So just what we did for horizontal lines, we take the x value, x1 and x2, add those together, and then what?
Divided by 2.
Divided by 2. So I'm going to put, let's call it g. If I add those together, I get 45, right?
Yeah.
Divide by 2, 45 over 2. And then my y coordinate is going to be 10. That point right there, g, is the midpoint of that blue segment, correct? Does everybody follow that? Let's go back to the pink segment. Okay? What is the x coordinate of any point that's going to be on that pink segment? 40. Okay? So I know it's going to be 40, so let's deal with just the y's then.
It's going to be 20.
Okay, so use 40 is the x coordinate, and then you take the y's down together, you get 40.
Yeah.
Divide by 2, you get
20.
20. And we get that point right there. Alright? Now, what's nice is that if I take a perpendicular line to that blue segment, and I force it to go through that point G, any point on that dotted line is going to have an x coordinate of what?
What is that, 22.5?
22.5. Okay? Now if I do the same thing over here on the pink through H,
40.
anything on that line is going to have a y coordinate of what?
40.
20. Where do you notice that those dotted lines intersect?
In the midpoint.
They end up intersecting at the midpoint of that segment that we were interested in, that orange segment. Okay? And you notice that that point, it's on the vertical dotted line, so it's got to have an x coordinate of 22.5.
Yeah.
And it's on the horizontal line, so it's got to have a y coordinate of 20. Okay? But now let's think about this. How could I have made this a little bit easier? I could have simply said that that coordinate right there, don't do that. That coordinate of 22.5 is that x value plus that x value divided by 2, right?
Yeah.
That y coordinate is that x value, that y value plus that y value divided by 2.
Wait, what is that?
Okay.
14. What's the other one? A?
5. Alright, so here's the formula we want to write down. the midpoint, so we use capital M a lot of times to reference that point, of x sub m, y sub m. So I'm just referencing, I'm putting those subscripts to remind myself that that x value and that y value came from the midpoint. Okay? We're going to have 3 different x's and 3 different y's, so I want to make sure we label them correctly. Is equal to x1 plus x2. So those come from your endpoints, the x coordinates in your endpoints, divided by 2. And y1 plus y2 divided by 2. Okay? We could have started class and I could have just put that formula up there and we just started getting to work and doing examples. Okay? But I like to show the logic, the reasoning behind formulas. I think it's silly to give you a formula and you have no background and understanding of where it came from and why we can use it. Okay? But I think that visualization there can help you. Especially, I think it comes in real handy, say you memorize 4 or 5 formulas for a test, and you get to the test and your mind goes blank, right? You forget some of those. Well, if you understand the progression that we went through to come up with that formula, maybe you can redo that progression on your test real quick or a piece of paper and convince yourself of what the formula is. I don't like to memorize things. I think memorization is only a short-term thing. It's going to leave you soon if you don't use it a lot. Okay? So if we can develop associations, develop an understanding of how they're created, that's going to allow us to keep this in our mind for a lot longer. Okay? Something I want you guys to realize is that this stuff that we learned today and tomorrow and Thursday is going to be used in probably about 3/4 of the chapters that we talked about this year. Okay? And they come up, you know, we'll see it in chapter 3 again, we'll see it in chapter 4, we'll see it in chapter 5, and we use these exact formulas, okay, to do certain things. Okay? Every chapter pretty much has a coordinate geometry section to it. And what happens in the past is that people don't heed that warning, okay, and they don't really worry too much about learning this now. And it's not until chapter 13 or chapter 12 that they realize, man, he wasn't lying to me. I really needed this stuff all year long. And it would have made my life so much easier if I would just learn it in September than having to worry about it in March or April. Does that make sense? Okay. And if you can learn now, it's obviously going to make that other geometry so much easier to learn later on. Okay. But this is all you got to do. If I've got a point A, okay, somebody Blaze, give me an ordered pair.
-5, 10.
-5, 10. Thomas, give me another one.
27, 18.
Alright. Okay. If I want to find the midpoint between those two things, that's how I like to stack them. You've all seen, like a lot of times when they give you in Math Excel, their points are kind of horizontally aligned with one another.
Oh, yeah.
And we're trying to do slope or something or this type of stuff. People will go like, I do this all the time. I go -10 and 7, but then I come back and I go -10 and 6, and I deal with those. Well, I can't deal with an X and a Y, can I, like that? And it's just a mistake that I make just because of the way they're lined up. So I always like to stack them. And now it's really easy. I'm either going to, if I'm doing slope, I just subtract top to bottom for X's and Y's. Or if in this case I'm finding a midpoint, I just add top to bottom. Does that make sense? And I don't accidentally do 10 and 27 because those should never be together in anything we do, right? Okay. Same thing with -5 and 18. So I'll find my midpoint. I'm going to take the x's, so I get -5 plus 27. I'll divide those by 2. And then I'll go 10 plus 18. Add those together, divide by 2. So -5 plus 27 is what?
-5 plus 27.
23.
22.
22 divided by 2 is? 11. 10 plus 18?
28.
Divided by 2?
4, 12, 14.
14. Okay? My suggestion to you, once you've found the midpoint, just do a quick sketch to make sure that it looks like it should be the midpoint. Now, I'm not going to sketch that here because 27 and 18 are pretty good sized points. I'll show you how to use GeoGebra hopefully later this week, maybe Thursday we'll get that on your computer. But a picture can help justify whether we've done something correctly or not. Okay? The hope is that when we graph those, the 3 points are collinear, and M looks like it's halfway between A and B. Okay? Is that pretty easy? Pretty straightforward? Okay? Now what happens is that we get a different style problem. So that's going to be half of what we do. But the other style problem, this is a problem you see a lot on ACTs, and you see a lot on the end of course exam. Okay? They do something like this. They say you have a point A, so let's call this, let's see if I can rename this. Okay, so we have endpoint A, and I want to show its ordered pair. Okay, and then we have a midpoint, so let's say that our midpoint is, let's go right there. We'll rename that midpoint M. Okay, we'll show its coordinate and value. The next thing they ask you, if you have an endpoint and you have a midpoint, they want you to project and see where should your other endpoint be. Does that kind of make sense?
Oh yeah.
Okay. And I used an array there. I don't really want to use that. Let's go. So they're asking, like, where do I stop this thing? Okay, where do I stop my array to find my other endpoint? So this is how we go about this. We have to use, and this is why we wrote this formula this way. We have to use this formula. It just organizes your work a lot easier. This formula is not just one equation. It's actually two equations. Okay. First equation is that x sub m is equal to that stuff. So the x-coordinate of your midpoint is equal to the x-coordinate of one endpoint plus the x-coordinate of your other endpoint divided by 2. So that's one equation that we gain from that formula. Another equation that we gain from that formula is y sub m is equal to that stuff. y1 plus y2 over 2. Is that doable?
Yeah.
Okay. So how many variables do we have in that red one?
3.
3. Yeah, x1, x2, and xm, right? But over here, is that something that we can consider?
Yeah, that's x1
x1
and y1.
and y1, and this would be
x2 and y2.
Careful.
XM.
xm.
And y.
The midpoint. Okay, so let's fill that information in over here in this on this red equation. Okay, so x sub m.
So it's 20 equals 10 plus x2 over 2.
Okay. And now how many variables do you have there?
1.
1, so you can solve that, right?
Yeah.
So let's multiply both sides by what?
2.
2, so I get 40 is
Equals,
equal to 10 plus x sub 2.
yeah, then you subtract 10.
Okay. So x sub 2
It's 30.
is 30, right?
Yeah.
So my x coordinate
It's going to be a 30.
should stop somewhere around 30, right? Or on that vertical line of 30. So it looks like my y value should be about 5, right?
Yeah.
Well, let's just go through the math and justify that it is 5.
15 equals
Okay, so y sub n, which is 15, so we're going to say 15 equals
25.
25, which is your y1.
Yeah.
y2 we don't know, right?
Nope.
All over
2.
2.
Times 2. You get 30 equals 25. And then minus 25, you get 5. Y2 equals.
Okay. So then we write our solution over here as x was 30, y was 5. And that's your midpoint. Okay. Oh, sorry, that's not your midpoint, that's your endpoint. That's your endpoint. Okay. And again, if you've got the picture, we can justify that pretty easily and say they're collinear. It looks like M is in the middle of the two endpoints and so forth. Okay. But you very rarely do they ask you a question on the ACT or the end of course exam to find a midpoint. It's always this. It's always this type of question. Okay. It's a little bit more involved, right? They're assuming that most people can apply just a general formula. They want to know, can you take that formula and manipulate it a little bit, okay, to find something else. And that's what we're doing here. Just because class is real short today, so we got about 4 or 5 minutes left, I think some of us are probably going to want another example of that. If you go to the website
Okay.
under 1.7, okay, right now it's not really working the way I want it to. So I got to see, I think it's just the code that I've got written in the background or whatever. But under 1.7, these two last videos here on this last row do a really good job of explaining and giving more examples of what we just did. The only thing right now is that when I click on it, for some reason, it's not letting me expand to a full screen. Okay, so I'm going to mess around with that and see what the problem is. Hopefully have that fixed by the time you guys get home tonight.
It's okay. We can look. We can just get a magnifying glass.
Well, that's another route. I mean, I don't know how clear it would be, but you could probably
Yeah. Oh, that's
zoom in on that.
That's just as good.
Okay, so control zoom or whatever.